Okay, back at the very beginning, I said we had two types of cells, galvanic and electrolytic. Electrolytic is electrolysis. It's the opposite of galvanic. Galvanic is a battery. Electrolytic needs a battery. Okay, so since it's the opposite of galvanic, it is not spontaneous. So it's going to have a negative delta E, and it would have a positive delta G. When we drew our reactions for our galvanic, we had two containers with a salt bridge. Here you would have your two electrodes in the same container and the wires hooking them to a battery. Now, oxidation is at the anode, reduction at the cathode, electrons still flow fat cat, so that's all the same. But the difference is that the polarity is reversed. We have a positive anode for an electrolytic cell. So what type of things are these? Charging a battery, plating metals, and the types of calculations we're going to do are how much metal will plate out, or how long will it take to plate a certain amount of metal. So we need to know how much electricity is passing through, and current is measured in amps, and 1 amp is 1 coulomb per second, and Faraday's constant, of course, has that. So if we want to know how much metal will plate out, we need the time and the amps. So let's look at some examples. So, how long will it take to plate this? Well, this question's incomplete. We need the amps. So let's say we want to know how long it will take to plate 1 gram of nickel from nickel ions if we are running at 3 amps. Okay, so here's what we want is our time, and we're going to find it in seconds because amps is coulombs per second, and so we're going to use it reversed here, or inverted, so that we end up with seconds on the top. So now if coulombs are on the bottom, we would need coulombs on the top. And here's where we have our Faraday's constant, 96,486 coulombs per mole of electrons. So moles of electrons is 2 per each 1 mole of nickel, because it's nickel 2 plus. Well, then we need moles of nickel on the top. I've been working backwards this whole time, but we're starting with 1 gram of nickel, so we're going to need grams of nickel. So this is the molar mass that we're going to need here. So I need the molar mass of nickel. So I'm going to look and see where I did this before because I need a periodic table. 58.69. All right, so we need the calculator. So we'll slide this over here so that we can see both of them. So 1 divided by 58.69 times 2 times 96,486 divided by 3. Okay, so that is going to take 1,096 seconds. Well, if we want that in a different time unit, well, we could convert that to minutes. And it would take 18 minutes. So our other type of problem is the opposite of this. It's going to start with the time and the current. So we have 15 amps. Well, we know that amps is coulombs per second. So we've got to get our hours into seconds. So in 1 hour, that is 60 minutes. And in 1 minute, that is 60 seconds. And we know that we have 15 coulombs per second. We know that we have 96,486 coulombs per mole of electron. We're going to a 4 plus ion here, so we have 4 moles of electrons for every 1 mole of hafnium. In 1 mole of hafnium, we have a certain number of grams of hafnium, molar mass. Oh, I didn't work it out on that example. Okay, let's find it. There we go, 178.5. And that's going to give us our grams of hafnium. So, calculator time. All right, 60 times 60, that's that many seconds. So I'm just going to start from there. And I'm going to multiply that by 15. Divide it by 96,486. Divide it by 4. Multiply it by 178.5. And I have 24.975. When I look at my significant digits, I have 25 grams of hafnium.